Now in this example, we're going to find the surface area of the portion of the plane z equals 8 minus x minus 2y in the first octant, which I've drawn here, not to scale, but there you have it. So we hit it 8 on the z, 8 on the x, right, because x and z have no coefficients, and 4 on the y, right? Now, this is not, it's a tetrahedron sort of. It looks like a tetrahedron, but of course we're only interested in the plane. We're only interested in the surface, not a solid, right? This is not a solid. So we want to find the surface area, and I'm going to add for myself x, y, z are in inches, just for the sake of it. Okay. Or let's say assume x, y, and z are in inches. Okay, so now how are we going to find the surface area? Well, the surface area is the double integral over the surface of 1 ds. Okay, so let me just I'm going to put that down here. The surface area is the double integral over the surface of 1 ds. Okay, so that's not going to be too difficult to figure out, but we're going to have to find all sorts of values for the region of integration in order to come up with this. Okay, so let's look at the region of integration. Now we could do this in any direction, but since the formula is written in the z equals xy, or a function of xy direction, I'm going to make the xy plane my region. So let me draw that region. So this is the surface up here, S. Right? Technically it's the plane. And then the region is in the xy plane down here. It goes out to 8 for the x and 4 for the y. So this is y, this is x. And it's a diagonal line, right, forming a triangle. So this is our region R that we're actually going to integrate over. All right. So why is that happening? Well, because on the xy plane, your z value is 0, right? So as a matter of fact, we can use that to solve for the equation of the line, or we could actually just find the equation of the line. It's not particularly difficult, but if it was something other than a line, you would set z equal to 0. So let me just write that. On the xy plane, z equals 0. So you'd say 0 equals 8 minus x minus 2y. And it's up to you which way you want to solve this. Do you want to solve this for x or do you want to solve it for y? I think let's do something different. We're used to going vertical all the time. So maybe let's do a horizontal this time, just for fun and variety here. Okay, so if we go this way, then we're doing dx dy. Right, remember how that works? Okay, so I would need to solve this for x. So I'd bring the x over. X is 8 minus 2y. That's the equation of that line. Lovely. And again, if you wanted to go vertical, you could, right? Y would be negative 1/2 x plus 4. I mean, so you could do it that way if you like. Okay, so now we know our region of integration. So if we look at our surface area, our region of integration is going to be, and then we're going to have 1 in here, and then we're going to have to figure out the square root of z sub x squared plus z sub y squared plus 1. I'll just say r dA, right, like that. Okay, so for my integral, my x is going from 0 over here on the left over to that line. So 0 to 8 minus 2y is my x. My y is going from the bottom of the triangle up to the top of the triangle. The bottom of the triangle is 0, the top of the triangle is 4. Remember, the last one always needs whole numbers, right? Your last integral. All right, so we need to go find the square root of z sub x plus squared plus z sub y squared. Okay, so let's go do that. Let's do it right over here. Make a little note to ourselves. All right, so the square root of z sub x squared plus z sub y squared plus 1 would be equal to the square root. Okay, so now z Remember that z was equal to 8 minus x minus 2y. So I'll make that note. Right? So z equals 8 minus x minus 2y. Okay, so z sub x would be negative 1. Z sub y would be negative 2. And we're squaring them. So that's going to turn them positive and make them bigger. So this is 1 plus 4 plus 1. So square root of 1 plus 4 plus 1, which is the square root of 6. All right, so this is going to be the square root of 6 in here. And then we're going to say dx dy. Okay, well, this is easy enough. The square root of 6 times x will be my integral. So this is going to be the integral from 0 to 4. I mean, you could pull the square root of 6 out. It doesn't really do anything. So it's a square root of 6x, and we're taking that from 0 to 8 minus 2y dy. So that, of course, is the square root of 6 times the integral from 0 to 4 of 8 minus 2y dy. Which is so easy I could do it. It's the square root of 6. The integral of this would be 8y minus y squared. So 8y minus y squared from 0 to 4. So that's 32, take away 16, which is 16 square root of 6. Now, because I made it inches for my units for my x, y, and z, then this would be, since it's surface area, it'd be inches squared. That would be the unit.